Hello and welcome back. In this tutorial we study about derivatives. First of all, let us think how derivatives came into the role. If you remember, when we study a linear equation, y equal y1 plus m times x minus x1, in order to write this equation we need to know only one point with coordinates x1 and y1. But in order to find slope m, we need to know 2 points, x1, y1 and x2, y2. Now the question is, can we find a formula which will provide the equation for the slope only with use of one point? Let us think about the following picture. So if we have some function here and we wanted to construct a slope, basically a tangent line at some particular point, how are we constructing the slope? We take one point here, point A, with coordinates x1, y1, and we have to take another point, point B, with coordinates x2, y2. Now, what if we take coordinates of point B very, very close to the coordinates of point A? So close that this difference between x1 and x2 will be hardly noticeable. Delta x, something like 0.0001, very, very small. So the difference between x2 and x1, very small. Thus the difference between x2 and y2 and y1 is very small. In such a case, we can find a new formula for the slope, which called derivative of the function at some particular point x1. So in other words, the slope is a derivative of the function at some particular point. Now we have some formulas for the derivatives, for the differentiation of the function. So first, if we have function looks like x to the power of n, the derivative of it, we put prime for the sign of the derivative, is equal n times x to the power of n minus 1. In order to differentiate exponential function, e to the power ax, where a is just any real number, the derivative of that will be a times e to the power ax. Derivative of logarithmic function, and we will study only natural logarithm here, is equal 1 over x. And then derivative of constant is always 0. So if I have some constant c, derivative of it always equal to 0. When we differentiate with respect of variable x. Constant c have nothing to do with variable x, so the derivative is 0. Let's do some examples. If we wanted to differentiate x cubed, well, I have to use the following formula with n equal to 3. So what do we have? By this formula, it will be 3 times x to the power of 3 minus 1, which is 3x squared. Let's say if I wanted to differentiate 1 over x squared. Well, look, I don't have any formula which would give me 1 over x to the power. What does it mean? It means that this function I have to introduce in the form that I can use formula x to the power of n. How would I do that? Let me remind you that if we have 1 divided by a to the power of m, this will be the same as a to the power of negative power. So any denominator we can represent as just a function, but with negative power. This is what I do here for 1 over x squared. I can represent 1 over x squared as x to the power of negative 2. And now look what happened. We have exactly this representation as x to the power of n, with n equal to negative 2. So now I just use the formula. It will be equal derivative minus 2 x to the power of negative 2 minus 1, which is negative 2 x to the power of negative 3. Now, if we wanted to find derivative of constant 10, let's say, again, whatever constant I take here, the derivative is always 0. If I want to differentiate function e to the power of 4x, in this case, 4 is just a constant a, like in the formula. Now, if we plug it in to our formula, it will be 4a times e to the power of ax. So 4 times e to the power of 4x. as numbers, we can differentiate sum and difference of the functions, and also multiplication function by constant. We have the following formulas for that. If I have function f of x, and I multiply this function by some constant k, then again, this constant k have nothing to do with variable x. So basically, we can move this constant outside of the differentiation. The formula will give us k, constant, times the derivative of function itself. When we wanted to differentiate addition or subtraction of two functions, or more than two functions, the derivative of the sum or difference of the functions is equal to sum or difference of the derivatives. So it's equal to derivative of the first function plus or minus derivative of the second function. Let us do some examples. Let us differentiate the following function. 3x squared minus 1 over x to the power of 4 plus e to the power of 1.2x derivative. Again, I have difference and addition of three functions. So by this formula, if I add and subtract functions, I first differentiate them and then I add or subtract them. So I have to write this as the following. First function derivative minus second function derivative. And for the second function, again, I have 1 over x to the power of 4. Like in previous example, I will introduce it as a negative power. So x to the power of negative 4 derivative plus the third function derivative. Now we use the following formula. I have multiplication by constant here, and I can pull this constant outside of the differentiation. So I will obtain 3 times derivative of x squared minus derivative of x to the power of negative 4 plus derivative of exponential function. And it's only left to use formulas. So we have 3 times, and our formula x to the power of n is equal to n times x to the power of n minus 1. So it's going to be equal to x to the power of 2 minus 1 minus, same formula again with n equal to negative 4. So it's minus 4 times x to the power of minus 4 minus 1 plus derivative of exponential function with constant multiplier a here, which is 1.2. So it's 1.2 e to the power of 1.2x. And now we can just simplify it. So we get 6x plus, minus and minus will give us plus here, x to the power of negative 5 plus 1.2 e to the power 1.2x. Let us do one more example. Let me differentiate the following function. 3 times natural logarithm of x plus 1 over square root of x minus 2 times cubic root of x to the power of 4 derivative. Again, we have addition and subtraction of 3 functions, so I will split this derivative into 3 functions. It will be equal to derivative of the first function plus derivative of the second function. So square root I will represent as power half minus derivative of the first function. And here cubic root of x to the power of 4 is the same as x to the power of 4 over 3. Now I have some constant multipliers which I can pull outside of the differentiation. So we have 3 times derivative of natural logarithm of x. Now 1 over x to the power half, again I introduce as a negative power. So it will be plus x to the power of negative half derivative minus 2 times derivative of 4 x to the power of 4 over 3. And now we use formulas to differentiate this. Derivative of natural logarithm is 1 over x plus x to the power of n derivative with n equal to negative half. So it's negative half x to the power of negative half minus 1 minus 2 times, and same formula used with n equal to 4 over 3. 4 over 3 times x to the power of 4 over 3 minus 1. And then you can simplify it, and basically we've done our differentiation. Now it's your turn to practice.